My name is Vijay Rameshan. My seminar topic is graph theory and its applications. Graph theory is a mathematical field that studies graphs, which are structures made up of nodes, vertices, and the edges connecting pairs of nodes. Graphs are highly versatile and from the foundation of many applications in artificial intelligence. Below is an overview of a graph theory concept and how they are applied in AI. Graph theory basics. First one, type of graphs. Directed with undirected graphs. Edges have direction in direct graphs, example A to B. While in undirected graphs, edges have no directions. Weighted graphs. Edges have weights, often representing costs, distances, or probabilities. And next one is unweighted graphs. Their edges are equal in value or importance. Next, trees. A connected graph with no cycles, often using hierarchical data representations. Key terms. Degree. The number of edges connected to a vertex. Path. A sequence of vertices connected by edges. Cycle. A path that starts and ends at the same vertex. Connectedness. Whether there is a path between every pair of vertices. Algorithms. Shortest path. Dijikstar's A star. Bellman-Ford. Next, minimum spanning tree. Kruskal's prims. Next, graph transversal. Depth first search DFS. Breadth first search BFS. Maximum flow. Ford, Fulkerson, and Edmonds Karp. Next, applications in artificial intelligence. Search and optimization. Pathfinding algorithm. Graph-based search algorithm like A star and Dijkstra's are used for navigation. Example: Google Maps, robotics, and games AI. Constraint satisfaction problems. CSPs. That is problems like scheduling, map coloring, or resource allocation are represented as graphs and solved using graph-based heuristics. Next, knowledge representation. Semantic networks concepts are linked by relationship. Here concepts are nodes and relationships are edges. For example, ontologies in natural languages processing. Knowledge graphs. Reasoning. AI system use graph structures for detecting reasoning, interference, and learning. Machine learning and deep learning. Graph neural networks. GNNs generally neural networks to graph structured data. Applications: social network analysis, molecular property predictions, fraud detection. Next, feature engineering. Graph theory is used to design features for structured data. Social network analysis. Community detection. Let's identify clusters of groups within social networks. Influence modeling. Analyze how ideas or behaviors spread in networks. Recommendation system. Leverage graph-based relationships between users and the items. Robotics and computer vision. Motion planning. Robots are graphs to represent their environment and find path to goals. Image segmentation. Graph-based methods group pixel or superpixels in an image. Object detection. Structural Relationship between objects are represented as graphs. Natural language processing (NLP). Dependency parsing represent sentence structures as directed cyclic graphs. Word embedding graphs help models relationship between words. Summarization and question answering leverage graph for extracting meaningful information. Bioinformatics and healthcare protein protein interaction networks analyze biological processes. Drug discovery predict molecular properties and interactions. Epidemi- Epidemiology model disease spread using graphs. Cybersecurity network analysis detect anomalous behavior in communication graphs. Fraud detection let's identify unusual pattern in transaction graphs. Next, access control models represent relationship and permissions as graphs. Challenges in applying graph theory in AI. First one is scalability. Large scale graphs are computationally expensive to process. Second one is dynamic graph. Many real world problems involve graphs that change over time, requiring dynamic analysis. Next one is graphs representation. Efficiently encoding graphs for machine learning tasks can be complex. Thank you.